Okay, in this video we are looking at polynomial inequalities, just one version of nonlinear inequalities. So say we wanted to solve this inequality here. Our goal is to find all x values that make this true. Our answer is going to be a set of intervals that satisfy this inequality. So one way we could do this, we know how to graph y equals this polynomial. We could just graph it and look at the picture. So say we wanted to graph, that's the same function. I just took off the greater than or equal to 0. Has degree 3, has a positive leading coefficient, so the end behavior is left arm down, right arm up. Our roots are -2, 3, and 5. Each has multiplicity 1, which means we pass at each x-intercept. So we could quickly graph the function. There's my end behavior. Here are my roots. And I'm supposed to pass at each one. Oh, kind of missed there. And now what I'm trying to answer is where, question mark, is this positive? So I could look at the picture itself and see where is the graph positive. So in this region back here, below -2, is the graph positive or negative? We're thinking vertically here. So is this positive or negative? These are negative y values. So all of this back here has negative graph. In this region, the graph is above the x-axis. These are all positives. In this region, the graph is below the x-axis. These are all negatives. And over here, in this region, the graphs are positive, above or below the x-axis. Below, above, below, above. What did I want? I wanted positive. I want to know where the graph is above the x-axis. So that's all of, let me use a different color here. That's all of these x values right here and right here. So we could write that as an interval. What's the smallest x value that works? I have a greater than or equal to. So this x value -2 is good, bracket, up until, what was this, 3? And then again from 5 to infinity. So union 5 to infinity. So that's the solution. These are all the x values that make this function positive. That's solving this inequality. Okay, that's one way to do it, is actually just draw the graph and look at the picture. I'm going to show you an alternate way, though, called a sign chart. And then alternately, if we wanted to, we could do the sign chart to help us do the graph. So we could use the graph to find the sign chart to do the solution, or I could use the solution to the sign chart to help with the graph. Okay, so let's do the same guy using a sign chart. So I wanted x - 5, x - 3, x + 2 greater than or equal to 0. So first thing I do is put in an x-axis and label all my zeros here. This is in factored form, so all of the roots get labeled. I don't really have to label anything else. So -2, 3, and 5. Of course, I got to put them in order. Now over here on the side, I'm going to list all my factors. I have an x + 2, an x - 3, and an x - 5. And we make this little grid. Okay, now I'm going to figure out the sign of each one of these factors in each one of these regions by just making up an x value. Okay, so x + 2, back here in this region, I'm just making up an x value. Now listen to my words here. Don't try going down. Go across That'll make sense in a minute. But if you try going down, you're going to get lost in your arithmetic. It's much easier to go across. I'm choosing any x value that lives in this region, anything less than -2. So let's just make something up. Let's say we chose x is -5. Just made something up. -5 plus 2, if I were to plug that in here, -5 plus 2 would be -3. That's a negative number. Okay, what if I chose an x value in here? Think of any x value between -2 and 3, anything. Maybe 1. 1 plus 2 would be 3. That's a positive. Okay, think of an x value over here. Anything between 3 and 5. Maybe 4. 4 plus 2 would be 6. That's a positive. And then anything up here. Maybe 7. 7 plus 2 would be 9. That's a positive. Notice where this linear factor changed signs. Where did this guy switch from negative positive? At the guy that makes him 0, at -2. -2 plus 2 would be 0. Below -2, this factor is negative. Above -2, it's positive. That's the way all of these are going to work. They're going to switch from negative to positive or positive to negative wherever they equal 0. So where's x minus 3 going to switch? Where does he equal 0? At 3. So he's going to switch from positive to negative at 3. Okay, so we could do it one piece at a time, or we could just do the whole line at once. So choose an x value back here. I already chose one, -5 minus 3. Plugging that value, -5, in here. -5 minus 3 would be -8. That thing is negative. In this region, between -2 and 3, if I plug in 1, 1 minus 3 would be -2. That's negative. In this region, in between 3 and 5, 4 minus 3 would be +1. That's a positive. Look, he just switched from negative to positive. And he switched at the guy that makes him 0, at 3. Once they switch, they're never going to switch back. So it has to be positive over here. And we could check it. 7 minus 3 would be 4, which is positive. Okay, same thing here. Choose any x value back here that you want. We've already picked one. -5 minus another 5 would be -10. That's negative. 1 minus 5, -4 is negative. 4 minus 5 is -1, is negative. Look, negative, negative, negative. He's going to switch at 5. 7 minus 5 is 2. That's positive. Remember, these factors can only switch from negative to positive once, and once they've switched, they've switched. Okay, so in this region, I've got a negative times a negative times a negative. That's 3 negatives multiplied together. 3 negatives would make the whole thing negative. This whole function is negative back there. In this region, a negative times a negative is a positive. Here in this region, I've got 1 negative. 1 negative is negative. And over in this region here, 3 positives multiplied together would be a positive. Now, really for the first time, I look and see, what did I want? I wanted positives. So where did I get positives? I got positives here and here. So what region was that? That's everything in between here. Those were all positive. And everything over here was all positive. Now, the only thing we got to worry about is, what about the endpoints? Do I include the 2, the 3, the 5? That's when we look and see, did we have a greater than? Or greater than or equal to. I did have an equal to, so I'm going to include these endpoints. If there were no equal to there, I would use open circles or parentheses. Because I have the equal to, I'm going to have closed brackets. And my final solution is, let's write it up here, -2 to 3, that region there, union, this region here, 5 to infinity. And then if we wanted, we could take this answer we just got and help with the graph. We know in this section the graph is negative, then it's positive. I mean, we could even kind of graph on top of this. The graph is negative, positive, negative, positive. Hey, look, that's my graph that I came up with right here. Look, it's the same graph. So these go hand in hand, graphing and doing sign charts. Okay, let's do another one. Okay, this one I'm not going to graph. I'm just going to do using a sign chart, but we could do it graphically if we wanted to. Okay, first thing we do, draw a number line. On this number line, we list all of our roots of any of the factors. So what makes this guy 0, and this guy, don't forget about him, equal to 0. Okay, let's go smallest to largest. He's 0 at -6. He is 0 at 0. And he's 0 at 4. Okay, over here we can go ahead and put in our dotted lines if we want. Trust me, it helps to put in these dotted lines. Then you can see I have 1, 2, let's maybe number these. 1, 2, 3, 4 different sections. And I got to figure out the sign of this whole thing in each section. And I could, if I wanted to, just plug in numbers into the whole thing and multiply it all out, but this is a quicker way. Okay, now on the side I list my factors. So my factors were x plus 6 cubed, x squared, and x minus 4. And I like to separate these with some more dotted lines so that we get this nice grid. Okay, don't forget about this region here, or this region here. That's where things get lost. Okay, so let's pick an x value back here. Choose anything you want. Maybe, I don't know, -8. -8 plus 6 is -2. When you cube a negative, it stays negative. So this guy right here is negative in this entire region. And in fact, we know it's going to change signs right here at -6. Once it hits 0, it's going to change signs, if it changes. And it can only change once. Okay, so this guy is going to change signs here. I bet it's going to be positive over in this region. So, I don't know, let's choose -4 as our x value here. -4 plus 6 is +2. A positive cubed is positive. Look, he switched over. Switched from negative to positive at the guy that makes him 0. And we could keep plugging in numbers here and here, but once it's changed, it's going to change. It switched from negative to positive, it's going to stay positive. So, I don't know, let's say we chose 2 here. 2 plus 6 is 8, cubed is positive. Say we chose 5 here. Remember, I can choose any x value I want in this entire region. Anything bigger than 4. 5 plus 6 is 11. Cubed is a positive number. What is 11 cubed? Don't care. Only care that it's positive. Okay, so this guy was negative. Switched right there. Became positive. Okay. What about x squared? Got to be careful here. When you square a number, it always becomes positive. This guy's never going to be negative. I don't even have to do any work. He's always positive. Even if I have a negative x value, when I square it, it's going to become positive. So he's always positive. Okay? X minus 4. Where's he going to switch? He's going to switch at 4. And in fact, we could just fill in our signs. Here's 4. He's going to be negative below it, positive above. If you don't believe me, pick an x value and check. -8 minus 4 is -12. Negative. -4. Or anything in between here. That might throw you off with the 4. Let's say we chose -1. That's between -6 and 0. -1 minus 4 is -5. That's a negative. Anything between 0 and 4. 2. 2 minus 4, negative 2. Negative. It's going to switch right there. X minus 4 is going to swap from negative to positive once I cross over 4. 5 minus 4 is 1. That's a positive number. Okay, now that I've got my sign chart filled in, I just multiply down. An even number of negatives is negative, an odd number is positive. A negative times a negative is a positive. In this region, 2 positives, still positive, times a negative is a negative. Here, 2 positives times another negative, or just one negative, is a negative. And over here, positive, positive, positive is positive. Okay, now what did I want? I want negative. Strictly negative. We've got to be really careful here. So that's all this stuff. This was all negative. And this was all negative. There's no less than or equal to here, so none of my endpoints get included. Even the 0 is not included. Even though that's in between here and here, if I plug in 0, 0 squared is 0, the whole thing would equal 0, and I want strictly negative. So I only want this stuff in between negative 6 and 0, and this stuff in between 0 and 4. So the solution would be negative 6 to 0, union 0 to 4. Okay, let's do another one. Okay, say we have this guy. First thing we always want to do is factor. If we're going to use the sign chart, we have to be in factored form. Otherwise, the sign chart doesn't do us any good. It's only things multiplied together that give you a positive or negative. So first off, I could factor a common factor of x out. And then this factors again. That would be x, x minus 3, x minus 5. That's your first step on every single problem. If it's not in factored form, put it in factored form. Okay. Draw your number line. On your number line, list all of your roots. Anything that makes any of your factors 0. What makes him 0? Don't forget about him. That's at 0. Where is he 0? That's at 3. And him at 5. Draw in your little dotted lines. Over on the side, list all of your factors. Don't forget the x. And again, I like to put in these dotted lines here. Break everything up into this nice grid. Now we have all these different sections. This section here, 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 and here. Everything below 0, between 0 and 3, 3 and 5, 5 to infinity. Okay, now let's do this one quicker. Where is x going to switch? What makes him 0? At 0. So he's going to be negative below 0, positive above. X minus 3 switches places at 3. Right here, it's going to switch from negative to positive. So he's negative below and positive above. X minus 5 is going to switch right here at 5. So he's negative below 5 and positive above. Pick some x values if you don't believe it. Pick something, I don't know, between 3 and 5. Say 4. 4 minus 5 is negative 1. It's negative. You can check each of these. Okay, then multiply down. 3 negatives is a negative. 2 negatives is a positive. 1 negative is a negative. 3 positives is positive. Now, what did I want? Don't forget, sometimes people forget this part. Am I looking for positives or negatives? I'm looking for negatives, so that's this region, negative, and this region. Now, do I include the endpoints? I have the equal to, so I would have solid dots here on all these endpoints, or brackets when I write it out in interval notation. So this is negative infinity up to 0, and then 3 to 5. Okay, one more example. Let's say we want to solve this guy. If I'm going to use a sign chart, I'm going to have to factor, and I want to know where things are positive and negative. In order to figure that out, I have to have this greater than or equal to 0 to begin with. If this side's not a 0, I'm going down completely the wrong track. First thing I want to do, get everything on one side and set this greater than or equal to 0. Then I can factor. That's x minus 3, x minus 4, greater than or equal to 0. I draw a number line. On the number line, I list all of my roots. 3 makes him 0. 4 makes him 0. Put in my little dotted lines. If you're not putting in the dotted lines, you're going to get the wrong answer. List the factors over here on the side. So we've got a few different regions here. Don't forget about this region back here. Sometimes this one gets forgotten. Everything here. Everything here. So I've got 3, 4, 5, 6 different pluses or minuses I have to put in. Okay, where's he going to switch? X minus 3 switches at 3. He's negative below, positive above. X minus 4 switches at 4. He's negative below 4, positive above. 2 negatives makes a positive. 1 negative makes a negative. 2 positives is a positive. Now, really, for the first time, I look and see, what did I want? I want positive. That's these two regions. All of this stuff. All of this stuff. I have the equal to, so solid dots, or brackets once I write it out. And that would be negative infinity to 3, the bracket, union 4 to infinity. That is the solution to this nonlinear inequality. By the way, we used to do these by graphing. We would graph y equals this function, and it would have looked like this right here. It points up because he's positive. There are the intercepts, 3, 0, and 4, 0. And we could look at the picture and say, hey, look, it's positive in this region and positive in this region. Or now we could use this to graph if we wanted. Okay, I'll make another video for rational functions in nonlinear inequalities, rational inequalities. Pretty much the same thing. Got little peculiarities we have to be careful of, but other than that, the same thing.